Hey guys, hi everybody. My name is Fabio. I'm one of the core devs at Push Protocol. And today we're going to be talking about what Push Protocol is, what problem it's solving, how it's solving, and by the end we're going to see different ways of how you can integrate Push Protocol into your mobile app, into your dApp, into your smart contract, or into your wallets. So the first thing is everything starts with a notification, right? So for example, whenever we receive a new email, we always receive a notification alerting us that we have a new email. Or whenever someone makes a transfer money to our bank account, we always receive a notification. So notification has been proving over the years that it definitely increases user experience, but also increases user engagement in your community. The thing is, before push, there was no way for protocols to reach out to the users, right? So protocols, they expect users to go back to the protocol themselves and fetch the information. For example, when will my ENS domain expire? Well, I have to check it. It's not something that I know by heart. And with a solution like Push Protocol, we can notify you, for example, 1 week before you lose your ENS. Or we can notify you before you lose money on Aave, before your collateral, you lose your collateral. Or we can notify whenever a new streams or Superfluid starts. So the problem that we have currently in the Web3 ecosystem is, first of all, for DAOs, as of now, DAOs that have no way to reach out to users to alert them that there is a new governance proposal, right? So for example, I'm part of multiple DAOs. How do I know there's a new governance proposal? Right, I have to go to Discord, I have to go to Twitter and be very active to see that there are new proposals. For a user experience, it would be way better if I receive on my phone a notification alerting, hey, new proposal 0x ABC has started, do you want to vote? Then you click on notification, then you can get redirected to Snapshot or any other application to cast your vote. For DeFi, the same thing. For user experience, way better to receive a notification before you actually lose money, right? I think we all agree on this. And for NFT marketplaces, it's way better UX when you receive a notification whenever someone places a bid on your NFT. I have an NFT, I want to sell it. Whenever someone places a bid, I want to get alerted. I don't want to give my email, I don't want to give any other information, and I don't want to go to the protocol myself to fetch the information. So the solution that Push Protocol is building, it is a open communication layer. That means that anyone can simply go to the network and fetch the notifications and the chat messages. It's all open. Everything is encrypted. All the chat messages are encrypted. Notifications, they can be encrypted and not encrypted. But the end is the communication. The layer is open. Anyone can simply fetch all the chats and notifications. The notifications, they are completely dynamic in two ways. First of all, how you're going to trigger the notification, it is completely up to the developer. Do you want to trigger notification manually? You can go. Do you want to trigger notification using smart contracts? Please go ahead. Do you have subgraphs and then you want to notify your users using subgraphs? You can. Do you want to notify your users on your server? You can. And lastly, the dynamic notifications, they're also dynamic in a sense that the notification itself, they can contain any arbitrary payload. It can contain a governance proposal. It can contain a YouTube video. I can receive a notification with a YouTube video. It can contain a random text. It can contain pretty much anything. There's no restriction of what the notification should look like. And the notifications, they are multi-chain. We're on Ethereum, we're on Polygon, Binance Smart Chain with more chains soon, and also non-EVM chains very soon. It is gasless. So for sending notifications, there's no fee involved, nor for receiving the notifications. And lastly, for me, that's the most important. It is the platform agnostic delivery part. That means is the user doesn't need to go to the Push Protocol interfaces to fetch the notifications or to fetch the chat messages. Push Protocol is an infrastructure protocol. We build this SDK sort of APIs. We have these nodes, but anyone can import the SDK and have the exact same look and feel that we have in our website or a mobile app in their own wallet, in their own app. So in the end, the users don't need to know that Push Protocol exists. We're just this infrastructure protocol that send notifications, that send chat messages, but how the users are gonna see the messages in a chat message, any front end can simply import the SDK and provide this experience to their community. So Push, we have sent over 30 million notifications so far. We have 5,000 different users that have opted to receive the notifications, and we have had over 500 different use cases of notifications. And we have notifications that go from DeFi, DAOs, NFT, metaverse, infrastructure, social, media, and services. And I think the difference, so we see that we have a lot of use cases for notifications. And what I like to point out is the notifications that are completely pick and choose. So for example, let's say that I'm a very active user on Lens. I just go to the Lens, I just opt in to receive notifications from Lens, and I will only receive notifications from Lens, nothing else. If at any given moment I want to stop receiving notifications from Lens, I just opt out. I sign a message, then I'll not receive notifications anymore from Lens. So the end user has 100% control of what the user wants to get notified, and the user can always opt out. And there's no fees involved into subscribing to this. So as I said, Push Protocol started as a hackathon project in ETH Global, like just a normal project. And we have been building for almost 3 years already. And we started with notifications, but now we have chat. And the thing about chat is that chat has been built on top of this notification layer. And why does it matter and why is it important? So first of all, the experience that we have in Web2 messaging system, we're bringing this into Web3. That means that whenever I receive a chat message on my phone, on the protocol, I will always receive a notification. So for example, whenever someone messages me on Push Protocol, I receive a push notification on my phone saying John.eth has sent you a message. Then it's like I have this like very similar user experience that we have on Telegram, for example. We also receive a lot of notifications on Telegram, so we're replicating this into Push. And of course, in the future, we're going to be able to fine-tune the notifications. So probably I just want to receive a notification for that user, but not for that other user. So then we can fine-tune this. But the goal is the end user will always have the control of what they want to get notified. And here on the left, we have our website. And here is the mobile app. And the idea is the website and the mobile app has been built using our own SDKs. And the idea for this is just to showcase that you can have the same UI in your own protocol. Of course, we provide the UI, but the idea is just that you can build exactly this in your own UI. Users don't need to go to Push to fetch all the messages or the notifications. So with chat, wallet chat, I mean, the applications are endless. We're just an infrastructure protocol, and how this system are going to be used is completely up to the developers. Here in the middle, we see that we have group chat. So a couple months back, we announced group chat and token-gated group chat. What that means is now we have a Web3 native way for people to communicate. So for example, I can create a group chat for my DAO. I can create a token-gated group chat. So that means is only people that are allowed to join this group is if they hold a certain amount of my governance token, let's say, and I can create a public group or a private group. So imagine I have my DAO, I have my token, and then I create a group where I say, okay, all the chat messages for this group is public, so anyone can see all the chat messages, but only if you hold a certain amount of my governance token, you can send messages. So you can see like how nice this can be for DAOs, for online communities. So we're building this framework for better and more transparent communication, so we don't rely on the current chat systems that we have in Web2. And of course, we have SDKs for both notifications, for both chats, and also for groups as well. We announced yesterday something very nice, which calls Push Video. So it's a new form of communication that we have built on top of Push Chat. So the Push Chat is built on top of notifications, and video is built on top of Push Chat. So we're building these communication Lego blocks that will be on top of each other. And Push Video is literally wallet FaceTime. I have a wallet, my friend has a wallet, so we can call each other. So here's me calling Madhur, he's a guy that works for us. So literally, yeah, so we're gonna announce the SDK for Push Video probably by next week. And the idea now, protocols or websites or mobile apps can now provide this service, which is wallet video calls. As of now, it's wallet. Very soon, we're gonna announce group video call. So I can just like create a group. I can call all my friends, but instead of calling their phone numbers, I'm gonna call their wallet addresses, and then we can just FaceTime everybody. Here I have two videos. So here on the left is just showcase how to log into the mobile application. But as I said, you don't need the mobile app to interact with the protocol. And here on the right, the video is outdated. We changed a lot the UI. But here on the right, we can see how we can start the video call. It changed so much already. I should have updated the video. But see, like we always receive notifications. Whenever someone calls you, you receive a push notification, say, for example, Madur.eth is calling you, like on my phone. And then I can click on the notification, then I can start the video call. And here on the left is how the notifications look like, and also how the chat looks like on the phone. See? Here in the end, we saw how the notifications and then all the chat here. Cool, I can go for some code demos, how to integrate push. Before I go that, does anyone has any questions so far about push? Otherwise, I just go into the code and then we can do the Q&A in the end. Cool, so let me go into the push staging app. So what does the app looks like? You as an end user, let's say I want to start receiving notifications from push. So how does it work? So we have our app here on mainnet. Let me just close everything. Cool. So on push protocol, we have a concept of channels. And the channels is exactly like a YouTube channel. So me as a user, I can subscribe to channels to receive notifications, right? So for example, there is this Shapeshift governance channel. I can just come here, opt in. All I have to do as an end user, just sign a message. And then that's it. Whenever there's a new governance proposal for a Shapeshift, I'll start receiving a notification. And the same goes for Lens, Snapshot, MakerDAO, Rect. So the user can completely go and pick and choose what notifications they want to get notified. Notifications, they can come here on your inbox, as we can see here. They can come here on the browser extension as well, see, or on your phone. Let's send a notification on our testnet, because I have a channel created here. So the first step is, if you want to send a notification, the first thing that I have to do is you have to authenticate yourself into the protocol so you can send a notifications. For this, you have to stake around $15 worth of push tokens into the protocol to prove that you're actually a legit person that wants to notify the users. But I have a channel here, call it demo channel. So let's send a notification. So the notification, there are three types: broadcast notification, targeted notification, or subsets. Broadcast means notify everyone who has subscribed to my channel. Target means notify one wallet, and subset means notify an array of wallets. In this example, let's just notify everybody. And on here on the right, I have just this wallet that I have opt-in to this channel here on the right. So let's send a notification, which means, hey, and my notification message, I'll call it notification message. Then I can add an image to the notification, and I can also add a call to action link, which is whenever the user clicks on your notification, they can get redirected anywhere. But for now, let's call this send just this notification. All I have to do is just to sign this payload. It is free, no money involved. And then I have received one notification here. If I come here to my inbox, notifications here. If I come to the browser extension, notifications here. And if I open my phone, my notification is here. If there is any wallet that integrates push, the notification will be everywhere. So notifications dispatched to everybody. We can send also the same notification here, but via code. All the code here is deployed already. It's on GitHub in our push protocol GitHub. So for sending notifications, we have this REST API SDK. To send notification, all I need is the push protocol SDK and the Ethers library, because we need to sign messages. So I just import the private key from the wallet that created the channel. So I created a channel with this wallet here. So there are two things. I can get the private key for this wallet, or we can do other thing that I do recommend. For staging, it's fine, but for production, I would add a delegate here, which means another wallet that can send notification on your behalf. I can add my other wallet here and then use the private key from this other wallet. So you don't use your private key for your main wallet. But since this is staging, fake money, there's no problem at all. The channel address here is going to be this address here, the address that created the channel. And the receiver, I'll be notifying this address here, which is this guy here. Just double check, 0xFD6, and this looks about right. This is my notification title, and this is my notification body. I'll change it to this, because why not? And this. Then I'm just calling the SDK, and all these properties here are on the SDK, on the documentation itself. And I'm adding a call to action link. Whenever I click on the notification, I'll be redirected to YouTube. And that's it. So if I come back here, so let me just run this. I send my notification. So if I come here, oh, I have this huge payload here. See, if I refresh here, the notification is here. And if I click on the notification, I go to YouTube. And also here. And also on my phone. Or any front end. We also provide React components, because the idea, a lot of protocols ask us like, hey, I want for my users to see the notifications on my own tab. I don't want the users to install anything from push. And that's the end goal. So, and for this, we provide React components for this. So for you, all you have to do is to import this. So have this React component here, which is called notification item. And you can install it from push protocol UI web. You just pass the notification array that you get from here by calling the SDK. You call the SDK, you get the notification array. Then you pass the notification array down to the components that we provide. So if I run this, how does it look like? See? All the notifications that we saw, they're also displayed here. The exact same notifications. So if I click here, I also go to YouTube. Nothing changed. See, the idea is just it's a platform agnostic. Anyone can display the notifications and chat messages. And also have this button here called opting to channel. Because for an end user to receive the notifications, the user have to opt in, to give consent to receive notifications from that protocol. Otherwise, the notifications go to the spam box. And what we say is, users can go to the push protocol app and opt in to receive notifications. Like I can come here and opt in to receive here. Or you can import, you can use our SDK to create a simple button. Then when you click, you can opt in here on your dApp itself. So let's say a user is filling a form like on your dApp, and then they say, hey, do you want to get notifications about this on your own dApp? Then you can display this opt-in button here. When the user signs in, the user clicks, signs a message. Under the hood, it's push protocol, but the user doesn't need to know that push protocol exists. We have chat as well. So here, how chat looks like. Let's see. So we also have video call here. And from the SDK itself, you can also send messages via SDK using our REST API SDK. So for this, everything is detailed in our docs. So let me just, where the docs are. If you go to docs.push.org, let's go docs.push.org. Here we have developer docs. And if you're a developer, there are two things. If you want to send notifications, you click here. Then you can send notifications from smart contracts manually using the dApp, using the SDK, using the scaffold solution that we provide, using subgraphs, or you can even customize your notification, right? You can add bold text, italic, bold and italic, add URL. And if you want to integrate chat, you have here push chat for Web3. Integrating push chat. So here we have some explanation about the chat SDK, but most of the explanation should be here on push SDK, SDK packages, REST API chat. Here's the documentation for chat where we explain how to send chat messages. And this code here, I copy and paste, and I paste it here. So if I go to push chat source, chat send message, this is how I send a message using the SDK. And we're gonna change this a lot, but for now that's it. So first of all, I get my user information from the protocol itself. I decrypt my private key, because whenever you log into push chat, we generate a new encryption keys for the user. We don't sign and encrypt the messages using the wallet private key, because we don't want to touch it. So we generate the only encryption keys that are encrypted using your main Ethereum wallet, or Polygon wallet, or Ethereum Binance Smart Chain wallet. Once you have the decrypted key done, you can just send a message. So if I come back here and I run this, message has been sent, and I send a message to this guy here, 0fd6, which should be this guy here, 0xfd6, which is nice. So if I come here to chat and open here, what did I send? I sent hello Tokyo. Hello Tokyo is here. Let me just change this to this. Yeah, looks about right. Let me send this. Yeah, I receive a notification and the message is here. That's pretty much an overview. All the different ways how to integrate push, everything in the documentation. We have been working a lot on documentation to make it super easy for developers. And then, yeah, I think that's it. So recently, Push Protocol has announced a new feature, which is called NFT chat. The difference between NFT chat and a normal chat is that the chat messages, they are tied to the NFT itself and not to the NFT holder. What does it mean to the end users? That once you transfer the NFT, all the chat messages, they're gonna get transferred as well. And the new NFT owner will have to set a new password that I'm going to explain later on. So the user can whether read the old messages or start from new and start sending new messages and not have the previous history, chat history. So that means that all the chat messages, they're indeed tied to the NFT and not tied to the wallet address of the NFT holder. If you want to get more information about this, there are two main ways of understanding better how NFT chat works. First of all, it's on our docs itself. So if you go to docs.push.org/developers, and here on the left, we have a section called Push Chat for Web3. And here we have an introduction about what push chat is. We talk about our mechanism for spam prevention. We talk about what chat request is, what's the process of sending messages, what's our vision for decentralization, what is verification proof for message verification, how messages are encrypted. And here at the bottom, we have the NFT chat section. This probably by the time you're seeing this video, this section will be different. But for now, this is what we have in our documentation and explains pretty much the NFT chat from the end user perspective. For the NFT chat to a normal chat, it is exactly the same. The way you receive messages, the way you send messages, the way that you call an NFT instead of calling a wallet address, the way that you create group chats, but instead of adding wallets, you add NFTs. It is completely the same. There is no difference. The only difference from an NFT chat to a normal chat, from the user perspective, from the user experience, which is very important, it is that by using NFT chat, you have one extra step, which is which we say here, which is that you have to select a secret key. It says here, when users log into the dApp to read NFT chat messages, they are prompted to enter their secret key to decrypt the chat messages. So this is the only extra step, and what it means is that, let's say you log into the dApp, whatever dApp it's implementing push protocol, is implementing the push SDK. If it's the first time you're opening up the dApp, then you have to or you're setting your password for the first time if you haven't done it before, or if you have chosen a password already, all you have to do is just type your password, and then we're gonna decrypt your encryption keys. Then with the decrypted encryption keys, the SDK will decrypt all the chat messages on the client. And this is what we're saying here. If an NFT chat does not have a secret key set, or if the user has just received an NFT and it doesn't have access to the previous secret key, they are prompted to create a new secret key. And this is another key difference between NFT chat and a normal chat. It is that once the chat itself, they're tied to the NFT itself. That means that once you transfer the NFT, all the chat messages, they are transferred as well. And then the new NFT holder has two options. The NFT holder can set a new password, then all the previous messages that were sent to the NFT, the new NFT owner will not have access. Or if I'm the previous NFT owner and transferred to someone else, and I transfer by other means the secret key that gives access to the chat messages, that the secret key that encrypts the NFT encryption keys, I send to that user, then the user will have access to all the previous chat messages. If you want to understand from a developer perspective how to integrate NFT chat into your protocol, it is exactly the same. There is no difference at all. The APIs are the same, the SDK is the same, no difference at all. There's only one difference that I said. It is that for NFT chat, instead of using wallet addresses as the identifier, we use a new format to specify the NFT, and that's the only difference. All the APIs, they are completely the same. So let me zoom in here. Can use this NFT account 1 as an example. So here's the, let me zoom in better. So here is how we call the account, the NFT account means. It's just the ID. Instead of using the wallet address in the SDK, you're gonna use this format here, which goes by NFT column EIP155. For now, we're only on EVM chains. Column, then the chain ID or of where this NFT is deployed. Column, the contract address. Column, the token ID for that NFT. This is the NFT ID into push chat. And once you do this, all the APIs, they're completely the same. Here, if you scroll down here, we have a section for NFC chat, and all the APIs for creating user, getting a user, getting chats, getting all requests, send messages, creating a group, and everything else is completely the same. And if you want to get access to this repo is public. It's as we can see here, it's our push SDK repo. You go to packages, then you're gonna see a new folder called examples, and here's where the code relies. You can run this code. So here I highly recommend anyone who's integrating push protocol, whether it's notifications or chat or even video, to take a look into this repo. As you can see here, all you have to do is set up your .env, and you do a npm start, and that should run all this file. So here you can see exactly how to read messages. You have all the SDK being used here, so you as a developer can just focus on building your protocol, don't focus about the integration. So the idea is you just copy and paste the code here into your own dApp protocol backend to integrate it. So I highly recommend taking a look, but the point of me showing this was just to show that all the SDK, all the APIs for the developer perspective, they're completely the same. Everything that the only thing that changes is the ID, NFT ID. That instead of passing the wallet address for the NFT holder, you're gonna pass the address on this format here.
Hey everyone, so I'm Madhur Gupta. I'm a developer at Push Protocol and I've been working on the push video side of things for quite a bit. I'm here to show you a demo of Push Video SDK and how can you use it on your React app, and you can leverage Push Video, which is a completely decentralized wallet to wallet video calling solution on your next app. Alright, so for this demo, we'll be working with this UI. So I've added a Rainbow Kit. This is a Next.js app, so I've added Rainbow Kit to it, and then it has got two input fields. So first is for the recipient address, the other is for the chat ID. This chat ID is the push chat ID. So this demo assumes that the sender and the recipient address, that is your address, and then the address you put here, have a push chat between them set up already prior to setting up push video. Alright, then we have got certain buttons, then some more data related to the video and audio streams, both local and incoming, and then certain placeholders for the actual local and the incoming video. Alright, so before starting with the code, I would like to point here that docs.push.org contain all of our latest documentation related to everything we create at Push Protocol. So for video SDK documentation, you can go to docs.push.org /developers and then push SDK, then SDK packages and details, the REST API, and for video. So this is a detailed documentation which explains everything that I'll be covering in this demo. Okay. So coming to the code, this is essentially a Next.js app in which I've added RainbowKit and Ethers as a dependency and style components, but you can of course use your own CSS solution as per your liking. Okay. So this is the index page that I've added. The first thing that I'd like to take you to is the initialization of the push video class. That's the first step that you need to do. So in order to store it, we'll be creating a React ref like this, and we'll store the video object on the current property of this ref. The next step is to create a React state. This state would be responsible to store all of the video calls data onto it so that you can use it easily in your React app. Now, next, we need to initialize the video call object. That I'm doing in a use effect. So basically, we create an object of the video class. This class's constructor requires the signer, the chain ID. So Ethereum is one, I mean the mainnet, and then Godly is five, and likewise for other chains. The decrypted PGP private key, the environment on which you are doing the video call. So this could be dev, this could be staging, this could be prod. Right now I have set this to dev, and then set data. So set data is essentially the React state changing function I showed you earlier. Yeah. So in order to get the decrypted PGP private key, you can call push api.chat.decrypt PGP key, and then you will get the PGP private key which you can use here to initialize the video object. Okay. The next thing we'll be looking at is basically how to fire a video call request. So let's say you want to call someone, then the first thing that you'll do is to initialize the video object. The second thing you'll do is you'll fire a video call request. So to do that, we'll basically set the data on the video call object. So as I mentioned earlier, video object ref.current holds the video call object that we created, and on that we have a set data function. So this set data function is essentially responsible for manipulating the video call data both on the React side of things and as well as on the class side of things, the things which are internal to the class. Okay, here I'm using immerse produce method to efficiently change the data and then set it. So basically in setting a request for a video call, I am assigning the local address as my address. So this is my address basically. And then in the incoming address, I am putting the recipient address. So that would be the ref.current.value. And then the status at the start would be initialized as we have just initialized the call. And then the chat ID. As I mentioned, this is the push chat ID between the two addresses you are trying to establish a call. Now, once this is done, we'll basically create a local media stream that is we'll turn on our video and our audio and then we'll create a media stream object that will be used in the video call request that will fire in the right next step. Okay. All right. So once the set request video call function gets triggered, and we basically would come to this use effect and this logic would run. So the idea is we check if the local stream is present or not. If it is present, which we have just created right here inside of set request video call, so this would become true. And as you have also set the status as initialized in right here, so it would fire a request for a video call. So it would require the sender address, the recipient address, the chat ID, which we already have stored on the data by calling set data. So I can simply call data.local.address to access all of those values now. Alright, so now once the request method gets triggered, essentially what it will do behind the scenes is that it will send a push notification to the recipient address telling them that the sender address wishes to create a video call with them. So the next step that we need to do is to basically add the logic to receive this push notification. And for that, we'll use push sockets. So the next step is to set up push sockets. So here I have added a React hook that basically sets up push sockets. So it would basically add certain socket events. The first would be the connect, then disconnect, and the last one would be the user feeds event. The user feeds event is where we'll receive the video call notification, and this is the place where we need to use the received data on the receiver's end, right? Okay, so we would be supplying you guys this entire next project, so not to worry. And in this socket hook, it will return the push socket, it will return a boolean if it's connected or not, and the latest feed item. Okay, next we need to establish the socket connection. So that would be if the socket is not connected, we call push socket dot connect, and in the use effects dependency we add push socket. Then finally, we need to add logic for receiving a video call notification. So this is essentially a use effect which has the dependency of the latest feed item. So whenever we receive a feed item, we set it here and then it updates and this use effect gets called. So the payload is extracted from the latest feed item. We need to search for an additional meta field inside of the payload dot data. If that is there, we basically check if that additional metas type is not equal to push video plus one. So if it's not push video plus one, that means it's not a push video call notification, it's some other notification, right? Now once that check gets passed, we parse the video metadata which is extracted from additional meta dot data, and on this we have a status property. This is interesting. So basically, as we saw, when the request method was fired, right here, so the request method is sending a status of initialized to the receiver's end. So once that is getting received, we call the set incoming video call method. This is something like you get a video call notification, and on the UI, we show up kind of incoming video call modal on the receiver's end with pickup and hang up buttons, right? So let me go through the set incoming video call function now. So this is kind of similar in a way to set request video call. So we are updating the data property by calling the set data function on the video call object. So I'm adding the local address, I'm adding the incoming address, I'm adding the status, I'm adding the chat ID, and as the initiator, I'm adding the sender's address because they have initiated the call, and then the signaling data. Then I await and create a video stream as we did right here. Coming back to the UI for a bit, we basically have those buttons here, right? I showed you earlier. So the first button is to initiate a request. So on click has the set request video call function, which I just showed you. Then this one. So this is the accept request button, which is to be used on the receiver's end to accept a video call request. So once the set incoming video call function gets triggered, right? This one, the status becomes push API dot video call status, that is received, and once that is received, this button gets enabled. Now we are ready to accept the video call request on the receiver's end. So accept video call request goes like this. So internally it would basically call the accept request function which exists on the video call object. So it is kind of similar to the call of request we had right here. So it has the sender address, it has the recipient address, it has the chat ID, and adding to that, it also has a signal data property, which is data.meta.initiator.signal. I have added it to data right here in the set data call. So I'm just reusing it right away. Sorry, this one. Yeah. So once this is called, it would send back another notification. So this notification would be from the recipient's computer to the initiator's computer, and this will have status is equal to received, right? So once a notification is received with the status of video call status dot received, we call the connect handler. So the connect handler is basically the final function which we need to call in order to establish a push video call. So it's a simple one. We just call the connect function and provided the signaling data which we have present on the video call metadata. Right. Going back to this handling of the video call notification, you would see certain other uh, call statuses as well. So that is retry received, that is retry initialized, and retry initialized again here as well. So just quickly going through those. So retry received is basically for retrying the received video call request. So you can read more about this one here in handling video call retries. This explains the logic of why this is here. So it's essentially part of the retrying logic we have on the SDK. And then this one, so this entire code, this one basically is also for the retry logic. So it's like if it's initializing retry and it's the initiator's computer, then we call the request function. Otherwise, if it's not the initiator's computer, we call the accept request function. Again, you can read more about this on this page. Okay, now we are good with the video call, right? So we fired the request, we received the request, then we accepted the request, then we finally connected the video call. Now, the things that remain are, let's say you want to toggle on or off your audio and video during the call, right? So in order to do that, we have these buttons right here. Okay. So to toggle your video, you can simply call the enable video function, which is available again on the video call object, and on the state is basically the boolean value which you want to assign to video. So let's say I want to like turn on my video, so I would call enable video with state equal to true, and if I want to turn off my video, I would call it with state equal to false. So this is basically the toggling logic that I've added. Similar thing for audio as well. Now, finally coming up to the hanging up part, let's say the call is done and then you wish to disconnect. You can simply call the disconnect method of the video call object and then your call would be disconnected. Now, lastly, here in the UI, I would like to go through the video players here. So I have added two video players as you can see. So the first one is for local video. Local video, I mean your own video. And then incoming video is the video that is getting received via the push video call. Just going through this video player component quickly. So this takes in a stream. This stream is essentially a media stream object that we have generated earlier while placing the video call, and then the local stream would be stored in data.local.stream, and then the incoming stream or the receiving stream would be accessible via data.incoming0.stream. In this video player component, it accepts a stream and then it creates a ref, a React ref, and assigns it to the video element. In the use effect, we basically listen for changes in the stream and the video ref. So whenever the stream updates, we assign it to the SRC object property of the HTML video element basically and give it the stream object we received, and then we simply call dot play. So that starts the playback. Alright, so that was me basically explaining the code of the push video SDK. Now let's quickly go through the app which we have just discussed on the browser. So I've already pasted in the recipient address and the push chat ID on the right window that you see. So the idea would be I would be calling the address on the left from the address on the right. So I'm ready to call the request function. So I'll click the request button. That would enable my local video, and then as you can see on the left window, the accept request button is now enabled. That means the notification for a video call has received the second computer. When I click on accept request, it would basically fire the second notification to the right browser window, and then we would call the connect function as we saw in the code. So right now the video call has been established. We can toggle on and off our video. So if I toggle the right Windows video off, it would reflect on the other window, and likewise I can do it for audio as well. I can re-enable them as per my liking, and then finally I can hang up. Right. Okay. So that was a quick SDK demo for push video, as well as a quick functionality demo for push video. I hope you liked it, and I hope that many of you guys would be integrating the push video SDK in your hacks in this particular hackathon. I hope you liked it. Thank you. Bye.